In this video lecture, I am going to discuss about the scheduling. What is the scheduling? Scheduling is the sequence or the order in which the process gets CPU for execution, which is basically termed as the scheduling, the sequencing or ordering of the process in providing them CPU for execution is termed as scheduling. And in a multi-program operating system, the number of process can resides in a particular state is given as in a new state there can be multiple processes. Also in ready state there can be multiple processes, but in a ready running state only one process can reside in that state, and in block state there can be multiple processes. Then comes what are the scheduling criteria. The parameter on which the scheduling is done, or we can say how the order of process is decided for scheduling, is termed as the scheduling criteria. There are 8 different parameters on which the scheduling criteria is decided. First is the burst time. Burst time is what? The time required by a process for its completion is called the burst time. And the arrival time is what? The time at which a process is loaded into the main memory, or we can say that the time at which a process arrives in the ready state is called the arrival time. And what is waiting time? Waiting time can be defined as the total time a process has to wait in the ready state as well as in the block state. For CPU bound process, the waiting time is how much time the process has to wait in the ready state, and for IO bound process, the waiting time is how much time a process has to wait in both the ready state as well as in the block state. And for a process, the waiting time should be minimum. And what is response time? It is the time taken by the CPU to respond to a process at that instance, or we can say that how long the process is waiting to get a response. And it should be also minimum for a process. And completion time means the time at which a process gets completed or terminated by the CPU is called completion time. And what is turnaround time? Turnaround time is defined as the total time taken by the process to get completed. We can say that it is the combination of the burst time and the waiting time of a process. Then seventh is the throughput. What is throughput? It is defined as the number of process executed per unit time by the CPU. And third, last is the eighth is the priority. What is priority? The scheduling of a process is decided upon the priority. Means the higher priority process will be executed first than the lower priority process. Then these are the formulas for calculating the turnaround time and the waiting time. So what I have said that turnaround time is the combination of burst time and the waiting time. So from equation 1 we can say that the waiting time is equal to turnaround time minus burst time. And B formula also says that turnaround time is also equal to completion time minus arrival time. Then scheduling algorithm. So the scheduling, these are the scheduling algorithms can also be said as there are two types of scheduling algorithms. So first is the non-primitive scheduling algorithm and second is the primitive scheduling algorithms. And these two scheduling algorithms is decided by the short-term scheduler or the CPU scheduler, which applies all those 8 scheduling criteria on the process which are in the ready state and based on two algorithms. What does non-primitive algorithm says? It states that once a process starts its execution in the CPU, it has to run until its completion without any interruption or preemption. Means once a process is allocated to the CPU for execution, it cannot be preempted, it cannot be forcibly terminated. It has to complete its execution first. Example includes first come first serve, shortest job first, and highest response ratio next. Then second is the preemptive scheduling. What is preemptive scheduling? It states that when a running process may be interrupted by another process due to the time sharing or maybe due to the arrival of a higher priority process. So by forcibly we are interrupting the process and giving the CPU to another process which has arrived, which has the higher priority than the process which is executing in the CPU. So example includes round robin, shortest remaining time first, priority scheduling, then multi-level queue algorithm, then multi-level feedback queue scheduling, etc.